Good morning, student. Today we are going to see what are the objection of open chain structure of glucose. In IR spectra, glucose molecule don't show peak related to carbonyl group, that is C double bond O peak is not obtained in the IR spectra of glucose molecule. Glucose molecule also does not give addition reaction with sodium bisulfide molecule. It also does not react with your Grignard reagent. It is also not react with Chips reagent, which is the specific test of aldehydic group. When glucose is treated with methanol and HCl, two type of glucosides were obtained, alpha and beta. Formation of this glucoside cannot be explained on the basis of open chain structure. To overcome all this, scientists Toland and Howard suggested two different structure, that is two different ring structure of glucose. This is the Toland's structure of glucose. According to the Toland's, glucose is 5-membered compound in which the first carbon, that is this carbon, and the fourth number carbon, that is this carbon, is linked by oxygen. So this ring structure is similar to that of furan ring. That's why it is known as furanase structure. This structure is basically given by Toland's. Howard suggested another structure in which this carbon, that is first number, and this is the fifth number carbon, is joined by oxygen, and it is known as Pyranostructure. Now we are going to calculate ring size of each structure. So we are going to give numbering from this oxygen. So it is 1, 2, 3, 4, 5. That's why it is 5-membered ring. And here is 1, 2, 3, 4, 5, 6. So it is 6-membered. Just see Howard's projection formula of alpha D glucose and beta D glucose. If we, in this formula, we see that at C1 carbon atom, if hydroxyl group is below the plane, then that glucose is known as alpha D glucose. If the position of hydroxyl group is above the plane, then it is known as beta D glucose. Now, how the ring size is determined in a glucose molecule? Out of these two structure, one structure is correct. Does glucose contain 6-membered ring or 5-membered ring? It is confirmed by following reaction sequence. Glucose first treated with your methyl alcohol in the presence of HCl. So one of the hydroxyl group, here this, is converted into OMe. Then this alpha methyl glucoside is further reacted with methyl sulfate in the presence of NaOH. So all other hydroxyl group which are present on this glucoside then converted into OMe. See here. So it is alpha O methyl 2346 tetramethyl glucoside is obtained when this glucoside is treated with HCl in presence of water, that is acidic hydrolysis is going on here. you then this methyl group is demethylated from here and we got OH here. So see the structure here. Basically your OMe converts into OH. Not all OMe converted into OH, only this OMe converted into OH. When this glucoside undergoes reduction, reduction is carried out with the help of dilute HNO3. We got 2,3,4,6 tetramethyl glucose. Now how this structure is obtained? Just shift a bond during reduction. This bond which are present in between oxygen and hydrogen shifted in between carbon and oxygen. Because of that, the linkage which join your C1 carbon and C5 carbon shifts to C5 carbon and oxygen. So this group basically converted into C double bond O and hydrogen goes away. Just see here, first change is seen at C1 carbon atom and second change is seen on C5 carbon atom. When this glucoside molecule is further treated with dilute HNO3, we basically obtain two products. First product is Trimethoxy glutaric acid and second product is dimethoxysuccinate acid. Now just see the structure of trimethoxy glutaric acid. In trimethoxy glutaric acid, we see that it is the acid containing 5 carbon atom. First, second, third, fourth, fifth. And this product is only obtained when this carbon contains carbonyl group. Otherwise, this product cannot be obtained during this reaction. So it simply means that your carbon number 1 and carbon number 5 in glucose are joined by oxygen linkage. Now what is Mutarotation? The pair of diastereoisomers which differ in configuration at C1 carbon atom are called anomers. So just see C1 carbon here, that is, what is C1 carbon? Carbon next to your oxygen is known as C1 carbon. So in this two structure, all the structure is same, their molecular formula is same, but the position of hydroxyl group in alpha D glucose is below the plane, while in beta D glucose it is above the plane. They are diastereoisomers of each other and therefore they called as anomer. The melting point of alpha D glucose is 146 degree centigrade, while specific rotation is 113 degree, while the melting point of beta D glucose is 150 degree centigrade and specific rotation is plus 19 degree. Now what is the meaning of Mutarotation? When we dissolve alpha D glucose in water or beta D glucose in water, the specific rotation value comes 52.7 degree. The change in specific rotation of pure anomer is due to the spontaneous conversion of one anomer to the other is called Mutarotation. Basically, when you dissolve your alpha D glucose in water, it spontaneously converts itself into beta D glucose, and when we dissolve beta D glucose in a water, it spontaneously converts itself into alpha D glucose, and because of that the specific rotation changes to 52.7 degree, and whole this spontaneous conversion of one anomer to other is called as simply Mutarotation. Now we are going to see mechanism of Mutarotation. Now for Mutarotation there is one condition: the solvent which we are take, it should be amphoteric. Now what is amphoteric solvent? Amphoteric solvent is that solvent which can act as an acid as well as a base, for example your water. If we take alpha D glucose molecule, and when we dissolve this alpha D glucose molecule in water, one of the molecule of water acts as an acid. So see here, the oxygen, which is the part of your glucose ring, the lone pair of oxygen takes away this proton. Because of that, this bond breaks away, while second molecule of water acts as a base, and it takes away this hydrogen from hydroxyl group. Because of that, just see here, this oxygen takes the proton here and rings open up, and it is converted into OH. When rings open up, there is chance of inversion and retention. If inversion is happen, we basically got beta D glucose. What is the meaning of inversion? It simply means that OH molecule comes above the plane. OH group comes above the plane. If retention is happen, same molecule get formed, and both the possibility are there. Therefore, when we dissolve alpha D glucose or beta D glucose in a water, we basically get equilibrium mixture containing 36% of alpha form. It is 36% and 64% of beta form, and this is the mechanism of Mutarotation. Now we are going to see what is the meaning of epimerization. The isomer of aldoses, important thing is here, this concept is only applicable to aldoses compound. The isomers of aldoses which differ in configuration at C2 carbon atom, it is important, which is differ at C2 carbon atom. What is C2 carbon atom? A carbon atom which is adjacent to your aldehydic group are called as epimers. The conversion of one epimers into other is called epimerization. Just see the structure of D-glucose and D-mannose. It is the open chain structure. That's why we don't write alpha and beta D-glucose here. So just see this carbon atom, that is C2 carbon, in a glucose molecule, the hydroxyl group is written on right side of your this carbon, while in D-mannose the hydroxyl group is written at left side. All the structure nearly the same, but there is change of this position of this hydroxyl group on right side in a your D-mannose molecule. Therefore, D-glucose and D-mannose are known as epimers, and conversion of D-glucose to D-mannose is simply known as so just see the conversion of D-glucose to D-mannose by epimerization process. When D-glucose is treated with bromine water, it is oxidizing reagent. So it convert your carbonyl group into carboxylic group first. When this gluconic acid is heated in presence of mild base near about 140 degrees centigrade, so basically tautomerization taking place. This double bond can easily shifted here. Because of that, this hydrogen gets away and comes on this oxygen just like this. So this carbon got OH, and there is double bond in between these two carbon atom. It is unstable diode, so it's go condensation. So how condensation going to be happen? So just see here, during the condensation, carbon number 1 and carbon number 4, that is hydroxyl group on your carbon number 1 and carbon number 4 reacted, and water molecule goes on, and we got basically gamma lactone. One of the hydroxyl group is converted into carbonyl, C double bond O. Second hydroxyl group goes off with this hydrogen here, and we basically got structure of gamma lactone or lactone structure simply. When this lactone structure is reduces with the help of sodium amalgam, we got D-mannose. Now what is the important thing? Just see here, during this step, that is unstable diol formation, your hydroxyl group which are present on C2 carbon atom shifted on right hand side, while in a glucose it is present on left hand side. Thank you very much. In next class we are going to see interconversion of monosaccharides. Thank you.